constant velocity. So the lab objective. The purpose of this lab was to record an object moving in constant motion and then track the object's point of mass using Tracker. Then we can use the data points from Tracker, make certain calculations to plug into GlowScript, and then produce a computational model. So then after that, we can chart both sets of data from Tracker and GlowScript, compare them, and remember in this scenario, velocity is constant and net force is 0. So an introduction. Before we get into the real section of the lab, there are some important things we need to cover. For instance, what graphs are being used for this lab. So we are primarily analyzing position versus time graphs. The x-axis is time, the y-axis is position. Some relevant equations for this lab. Since we're focusing on position, velocity, net force, and time, we will be discussing the momentum update formula, the velocity update formula, and Newton's second law. And a quick preview is that the result of this lab ended up being that both lines I plotted in Excel using the data from Tracker and GlowScript had slight deviations, but both did show that my object was moving at a constant rate, and I'll explain these deviations later. Okay, here are the important equations. We have Newton's second law, which is F net equals ma, and we get there using momentum concepts, such as the fact that momentum is mass times velocity, and we know that over here dv over dt up in the corner is equivalent to acceleration, so we get mass times acceleration. Average velocity, that's just change in position over change in time. The momentum update formula, super important because the momentum update formula helps us to get the velocity update formula. We know that momentum, as I said before, is mass times velocity. You can cancel all of those masses out, and then you end up with the final velocity equals the initial velocity plus f of net divided by m change in t. And as I've said before, f of net is 0. So in this case, we're going to get final velocity is equal to initial velocity, which makes total sense considering that this entire lab is based on constant velocity. So now for the fun part, Tracker. So for my object, I chose to use an empty can. So emptiness is important for motion. If it had any sort of liquid in it, that could affect my data, that could affect the motion. After I filmed the video, I obviously put it through Tracker here, and the system is the can, and the motion starts from the origin, which I used when doing my axes. And I also calibrated the can. So I calibrated using the size of the can, which is 0.159 meters, and here is when it's moving. So when it's moving, as you can see, it tracks all of these data points, and I can use those later on in GlowScript. My GlowScript data produced from Tracker. Or sorry, my data that I produced from Tracker that I can use now for GlowScript. So here we have my time, we have position. I highlighted these two columns. They are super important for when I start putting them into GlowScript. We are not focusing on the y-axis at all. We're just focusing on x because the can is moving in the horizontal positive x direction. And as you can see, it is pretty constant. And remember, the time interval is 1.1 second. This is going to be very important later on. Here is GlowScript now. I can take the data that I got from Tracker and now put it into GlowScript. So I highlighted some things that I needed to edit in GlowScript. For instance, the time interval needs to be less than 1.2 seconds because the interval is 1.1 seconds. The net force should be 0. We have two formulas that I had to insert so that GlowScript could do the calculations for me. We have the velocity formula, the position formula, and then down here, how I got velocity as 0.606 is I took those data points from Tracker, did the average velocity formula, and got 0.606. All right, GlowScript data. This is my position versus time graph. You can see the model up in the top left corner, and then you can see the velocity. It's looking pretty good, looking constant and everything. And then here, I can copy and paste the Tracker data and the GlowScript data, put them through Excel, and we have this plot. As you can see, the lines, they start off very similar, and then they deviate as time passes, and there's tons of reasons for this. For instance, I could have calibrated the can wrong. I definitely could have got it skewed a bit. So there could be inconsistent tracking. There's definitely no way that I got the point mass correct each and every time. Nothing is ever constant. There's definitely forces acting on this can that were not taken into consideration. And the can, like I said, might have been slightly tilted, but overall it does show constant motion. And just in the corner here, remember orange is Tracker, blue is GlowScript. All right, so now we have some what if questions. What if the positive x-axis and the negative x-axis were interchanged? So actually, what would happen here is that the slope would no longer be positive, it would be negative. So your slope, like, it would still be the same number and everything, but now it has a negative in front of it because we are now changing the positive x-axis to the negative x-axis where velocity would be now negative. So that is what would happen in this scenario. For here, is it possible to say how many forces are added together to give a net force of 0? This is a complicated one because not really. There's actually a ton of forces going at it here. For instance, we have gravitational forces, we have friction, we have the fact that I pushed the can. We might not have saw that when I played my tracker video, but that's because I did the time frame a certain way. But I pushed the can, and that definitely is not accurate. You know, gravitational forces between multiple objects, and we also have like air resistance and things like that. We're not resistance, but just the air in general. And we also, like I said, friction. We would have to have a super, super small coefficient of friction for that to be 0. There really isn't such thing as like perfect constant motion. There are always forces. So thank you for watching this video. Goodbye.